If you were like Dave and me and graduated high school in the 1980s, you probably remember learning that our solar system had 9 planets, and Pluto was proudly one of them. But somewhere along the way, that changed. Today, Pluto is called a dwarf planet. In this video, we'll explain how Pluto lost its full planet status and introduce you to some of the other fascinating dwarf planets. Icy worlds, rocky objects that exist beyond Neptune. A lot has been discovered since we sat in those high school science classes, and astronomers are still finding new and surprising objects out there every day. I'm Tom.
I'm Dave.
Join us as we take a quick journey to the outer reaches of our solar system. Like I said, when we were in school, the solar system had 9 planets, and Pluto sat proudly at its edge. It was tiny, cold, mysterious, but it counted. Then, decades later, astronomers discovered new worlds that forced us to rethink everything we thought we knew about the edge of our solar system. Let's take you through the solar system updates from about 1990 to today. For most of history, the first 6 planets were observed by the naked eye, and early telescopes later revealed many of their moons. Uranus, though fairly visible without a telescope, was long mistaken for a star until William Herschel identified it as a planet in 1781. This sparked a wave of discoveries: Ceres, Pallas, Juno, Vesta, which were all initially classified as planets. In 1845, Neptune was discovered after irregularities in Uranus's orbit suggested the pull of another massive body. However, by 1851, astronomers had identified at least 15 small planets between Mars and Jupiter. Over time, they recognized these bodies as part of what we now call the asteroid belt, not true planets. The reclassification was gradual and uncontroversial. It was based on emerging consensus rather than formal debate. Neptune, with its size and stable orbit, retained its planetary status, while the search for new worlds continued. Pluto was discovered by Clyde Tombaugh in 1930 and was classified as a planet until 2006. It was a very odd planet compared to the other 8. In this simple picture, you can see its orbit is less circular than the other planets. Its farthest point from the sun is 80% greater than Neptune. You can also see that Pluto's orbit is on a very different plane or disk than the other planets. Pluto is 17 degrees off from that plane, and most of the other planets only 1 to 3%. What you can't see in this image is that Pluto is 3 times larger than the largest asteroid, but it's only 1/2 the size of Mercury. By diameter, it's 1/60th the size of Jupiter. But it was generally accepted with a little hesitation as the 9th planet, and that's how the solar system was thought to be. That's what we learned in high school, and we thought nothing more was to be found. But in 1951, though, Gerard Kuiper theorized the existence of more objects beyond Pluto. It was not until 1992 before an object in the theorized Kuiper Belt was observed. By 99, they had found 1,500 more, but none were more than a third the size of Pluto. And these objects were similar to Pluto, but nothing like the other 8 planets. They were much further from the sun, with significantly elongated orbits. Most were on a different plane than the 8 largest planets. That is, the 8 planets looked like a disk or plate, but Pluto and most of the other objects were well above or well below that plane. This picture is a view of the Kuiper Belt in 2015, but it shows Pluto's unusual orbit and the broad spread of Kuiper Belt objects. Pluto is the white line, and the picture was originally created to demonstrate the flight path of the New Horizons space probe, the yellow line starting from the Earth in the center of the picture. What you can also see with this 3-dimensional view is the sense of dispersion of those Kuiper Belt objects. By 2005, there were too many objects with new and unusual orbits and sizes that had been identified. It seemed like more and more would be identified as time went on. At the same time as the Kuiper Belt objects were being discovered, other astronomers were finding exoplanets in other solar systems. Some of them were even larger than Jupiter. So the question was broader than just our solar system. It was a fundamental to definitions of objects throughout the ever-expanding view of our universe. Mike Brown, a leading astronomer of that time, asked around and created a list of layperson definitions of a planet. Here are some of the responses he received. It's a large rocky body.
That's very inaccurate, since the 4 largest planets are primarily gas and don't have a rocky crust like Earth and Mars.
Well, what about things with moons?
Oops, Mercury and Venus don't have moons,
You can see it with your eyes.
but you can't see Uranus, Neptune, or Pluto without a telescope.
What if it's anything as large as Pluto that orbits the sun?
That makes Pluto the de facto minimum and truly an emotional, not science fact based choice.
Maybe you can see by these definitions, and maybe you can identify with one of those definitions, but clearly the definition was not clear to everyone. So in 2006, the Astronomical Union, or IAU, addressed the inconsistencies. Going into the big meeting, it appeared the consensus was Pluto would be the definition of a planet. Eliminating Pluto would just be too emotional. Then they surprised many astronomers by going a different route and defined planets in a way that left Pluto out of the planet definition. They also created a new category of dwarf planets that included Pluto and other major objects. The 8 planets in our solar system clearly have 3 core characteristics. They orbit the sun, they have a round shape and size, and an orbit that's cleared of other objects. They may have moons that are captured, but their orbit is clear of other objects. Pluto passed the first 2 tests. It orbits the sun, it's round due to its own gravity, but it shares its orbit with at least 16 other objects called Plutinos and has thousands of icy neighbors in the Kuiper Belt. That's why it was reclassified as a dwarf planet. It's still the same Pluto. Its place in the solar system just classified more precisely with the rest of its posse.
Since 2006, astronomers have come to see that beyond Neptune lies a vast zone of icy bodies called the Kuiper Belt, the leftover debris from the solar system's formation. It's home to Eris, Haumea, and Makemake, worlds near Pluto size, along with countless smaller objects. As surveys improved through the 1990s and early 2000s, astronomers kept finding more and more of these distant worlds. And it became clear that Pluto wasn't an oddball at the edge of the solar system. It was part of a whole population of smaller bodies, a community that we simply couldn't see with the 1980s technology. The more objects we discovered out there, the harder it became to justify treating Pluto as the 9th planet, while ignoring dozens of cousins with similar basic characteristics. In other words, Pluto didn't shrink in importance. Our view of the solar system grew, revealing that dwarf planets are common, not rare. Sedna was the first hint that the outer solar system wasn't as empty as we thought. And now we found another weird distant world nicknamed Ammonite. Both of these objects travel on huge, stretched out orbits that take them way beyond Pluto, so far out they barely feel the sun's pull. They don't fit neatly into the Kuiper Belt or the Oort cloud. They're stuck in this in between region that we really don't understand yet. What makes Sedna and Ammonite interesting is that their orbits don't line up with the rest of the solar system. That's why astronomers think something big and far away, maybe a planet 9, might be nudging them around. We don't know yet whether that planet actually exists, but discoveries like Sedna and Ammonite make it clear that Pluto isn't alone out there. There's a whole outer neighborhood we're just starting to uncover. If the Kuiper Belt is a disk, the Oort cloud is a giant bubble way out past the Kuiper Belt, a frozen halo that may stretch halfway to the next stars. It's filled with trillions of ice fragments left over from the early solar system. And every so often, one of these objects gets nudged and falls inward, becoming a long period comet. We can't see the Oort cloud directly, but we see its fingerprints in the orbits of these comets. The reason it forms a bubble instead of a disk is that these objects were scattered in all directions by the giant planets when the solar system was young. Over billions of years, passing stars and the gentle pull of the Milky Way reshaped that swarm into a vast, almost spherical shell. So when a long period comet appears from a random direction in the sky, it's like hearing a distant echo from the solar system's earliest days, a reminder of this invisible ancient cloud that surrounds us. We've also tracked new objects from outside our solar system. Oumuamua, which showed up in 2017, was the first confirmed visitor from another star system, and it was a strange one. It had no visible comma. It tumbled in an odd, elongated shape, and it even sped up slightly as it left the sun, which led some people to wonder if it might be artificial. Later studies showed these quirks can be explained by natural processes, like hydrogen escaping from deep inside the object. Then in 2019, we saw 2I Borisov, another interstellar object. But this one looked and behaved much more like a typical comet, complete with a bright comma and tail. Its chemistry was unusual, especially its very high carbon monoxide levels, which suggest it formed in an extremely cold region around another star. And because Borisov fit the pattern of a normal comet, it didn't generate the same level of speculation. In both cases, though, the evidence points to natural objects from distant planetary systems, not anything artificial. 3I Atlas, discovered in 2025, is our third confirmed interstellar visitor. And this one very clearly behaves like a comet. It has a noticeable coma and tail, and its orbit is extremely hyperbolic. So we know it came from outside the solar system. Early on, a few people suggested it might be artificial, mostly because some of the first measurements looked unusual. But as more data came in, those ideas fell away. Telescopes detected normal cometary gases, including a strong signal from hydroxyl produced when sunlight breaks apart water. And nothing about its motion suggests it's under any kind of control. Its chemistry is interesting, especially the high levels of carbon dioxide, and features like its odd polarization of light and anti-tail are uncommon, but still fully explainable by known comet physics. So while it inspired some speculation, everything we've observed points to 3I Atlas being a natural interstellar comet, not an alien spacecraft as noted in several alarmist social media posts.
We hope you have enjoyed our little astronomy update. The story of Pluto and his posse that live out past Neptune reminds us that science isn't about being right once, it's about refining our views based on what we know and as our tools improve. Each discovery adds another piece to the puzzle, turning mystery into understanding. The solar system hasn't changed. It's our perception that has changed it from Ptolemy's Earth centered view on the left to the complex sun centered and diverse picture that we can see today. Thank you for joining us.